Okay. Your second module start with the sensors and actuators in automotive electronics. So in this chapter, we are going to discuss the different types of sensors and um, actuators. Okay. So basically, if you go for sensors and actuators definitions, a sensor provides the measurement for important plant variables. Basically, sensors are the devices which is going to sense a particular environment, and it gives the output in the form of analog. You could have studied in your electronics wise. Okay, so here what we are going to do, a sensors provides measurements of important plant variables. Here plant is nothing but your vehicle or a car, whatever it may be. Example like vehicles, whatever the vehicles is there, in the vehicle some parts, some devices you want to monitor, means we are going to consider as that as a plant variables. Variables is nothing but your datas. Okay, variable is nothing but a datas. Okay, so in the format, in a suitable format, it will give to the microcontroller. So here also little bit mu c or mu p will come into the picture. Okay, mu c and mu p, because all the sensors whatever we are using, we are supposed to connect it to the microcontroller or a microprocessor. Okay, so basically a sensor means it converts one form to another form. It's a transducer which convert one form to another form, environment condition into electrical form. So basically what happens, it will be in the output in the form of analog. Okay, which is given input for your microcontroller to take a certain decisions. Okay, I hope you are following. Sensors provide measurement of important plant variables in a format suitable for a digital microcontrollers. Okay, so this is the definition of your sensors. When coming to the actuators, actuators is nothing but your convert. Basically, if you speak, it converts a electrical signals into mechanical actions. Okay, electrical signals into mechanical actions. Okay, so in according to the textbook definition, actuators are the electrically operated device. It is electrically operated device that regulate inputs to the plant that directly control its output. So it is little bit tedious, like definition they have put up here, but in simple way if I tell, okay, it converts your electrical signals into mechanical actions. Okay, electrical signals into mechanical actions. So example, like your example here, if you take it, okay, like a motors. Okay, if you take it your examples here, it is considered as a motors. Okay, what is the job of motors? If you give a electrical signals, like it may be DC or it may be AC, whatever it is there. Okay, if you give a electrical signals for that, it will try to rotate in a particular direction. It may be anti-clockwise or it may be clockwise. So that is the definition of your actuators and your sensors. Okay, sensors, it measures the certain plant data. Okay, and it will be given for your microcontroller to take a decision, like your temperature. Okay, like your air pressures. Okay, such way what happens here, the sensors are used. Actuators means some rotational operation, mechanical actions. So if you give a pulse, it will convert into mechanical actions. If you give a electrical voltage, okay, it will convert into mechanical actions. So such way actuators and sensors are used. Okay, that is only here example, it is fuel injectors. Okay, fuel injectors are the electrically driven actuators that regulate the flow of fuel. Okay, as I told you, in the engine system there will be inlet valve and outlet valve, right? So your fuel injectors are the devices which will be connected to your engine system, near to the engine system. Whenever your pulse is given, electrical signal is given, what happens, the fuel injector, it will start to open the nozzle or a valve of a fuel tank, okay, which will be flow into your engine system. Okay, so that's why it is called as a fuel injectors are electrically driven actuators that are regulated to flow of fuel into the engine for a engine control applications. Okay, so this is the one of the example. Like such way we have a lot of examples with the actuators and the sensors that you are going to read it in your this module. Okay, it's very easy, and you have to keep in mind that diagrams are very important. Okay, so diagrams carries maximum marks in your VT question paper. Okay, then next topic is automotive control system application for sensors and actuators. As we have discussed with the definition, let's see where and all they are going to use these things. Okay, sorry, just a minute. Okay, so here a block diagram represents where and all your actuators and sensors are used. Okay, so the first part is inlet air. Okay, TPS. Okay, I'll tell you what is TPS, MAF and all. So that's the first part is a total plate sensor, manifold airflow control systems. Okay, your engine system, EGO, EGS, EGR. Okay, so these are all one of the flow of your diagram. With this, these sensors, whatever it is there, it is being connected to the engine control systems. Okay, here engine control system is made up of microcontroller or a microprocessors. Okay, microcontroller and a microprocessors. So based on the input of TPS and MEF, okay, the output is given for your fuel injector and ignition system. Okay, fuel injector and a ignition system. Keep in mind, see the arrow mark. These are all the sensor part. These are all called as a sensor part. Okay, total plate sensor and airflow, mass airflow sensor. Okay, which will give a input for your engine control systems. Once your air is inletted, okay, the controller, what it will do, it will send a command to the fuel injector also. Okay, the fuel will be injected into what? Engine system. Okay, engine will start to operate. Already we have saw in the previous module how the engine operates. Okay, so based on the fuel and your air, what happens, it will start to operate. During that time, ignition system, as we know that in the previous module we have discussed about in ignition system also, it is made up of spark plug with a transformer, everything, and distributor. So that it is a command given for your from your engine control system, command is given for your ignition system, which will on your or operate with your engine system. Okay, so such way what happens, this is the flow of your system. Then it will come for EGO and EGR. So basically, as I told, after your engine operation, like 4 cycle, the 4th cycle is exhaust. What is exhausting? Unwanted burn things, whatever it is there, it will be outletted by your engine. But that also we have to monitor. That is done by a sensor called EGO and a EGR. Separately, I will take it. What is EGR and EGO? Okay, so that is also this EGO input is given for your engine control system. Now ನೋಡಿದೀವಿ ಏನಂತ ಹೇಳಿದ್ರೆ emission test we used to do it. In the emission test, what we are going to do, like these things, these parameters, engine parameters, whether it is polluting the air by exhaust, that and all we are going to calculate, or we are going to monitor. Certain range will be, certain regulations is being given by the government. Okay, so based on that, the evaluation will be done at the emission test. Okay, so such way what happens here, that input as a feedback will be given for the engine control system, once again to control these things. Okay, with that also we have different sensors and actuators are crankshaft, camshaft, position sensors. Okay, camshaft or crankshaft position sensors are connected here, and coolant temperature sensor. We know that why coolant are required. Okay, after certain range, after certain temperature, the engine will get heated up. Okay, so once your engine is heated up, we have to make a cool for that. Means we have to maintain a certain cool temperature for that. For that, what you are going to check? Coolant temperature sensor. So once your coolant temperature sensor exceeds certain range, the radiators, you could have heard of radiators, so radiator fans will get on to make in such a way that engine will get cooled. Okay, so such way this diagram is made up of your sensors and actuators. Okay, so I hope you have followed. Okay, once again I'll explain this topic. Okay, so this is nothing but a automotive control system with the application of sensors and actuators. What are all the sensors, what are all the actuators you are going to connect it with the control systems? Okay, engine control systems. Okay, so the first one, two things are very important for engine. Okay, keep in mind, one is air, another one is fuel. Okay, so here inlet air will be given for your total plate sensor, means total plate sensor will control the inlet of your air. So Mars airflow sensor will be calculating how much air is inletted into your engine system. That feedback is given for your engine control system. So here engine control systems is nothing but your mu C and a mu P. Okay, and what happens based on the input? What happens? It will send a command for a fuel injector also. So fuel injector, what it happens? The nozzle will be open and fuel will be injected into your engine system. So we know that engine system works with a 4 cycle. Okay, inlet and your compression or combustion with your power generation and exhaust. Okay, so during the power generation, ignition system also it will be controlled by engine control systems. So based on the inlet of your air and fuel, the engine will start to work. Okay, then after some time exhaust, what happens? Out unburned things or burnt things, whatever it is there, it will be outletted through the wall. That is monitored by EGO. Okay, that is once again it will give a feedback for your engine control systems. So this is one flow. And one more thing, EGR also it is controlled by your engine control system. That also separately I will take it. So with that, we have a crankshaft, camshaft position sensors and a coolant temperature sensors. Okay, so these are all the things which you are going to learn. Each and every block you are going to learn in this module. Okay, I hope you have understood these things. Well, next we'll move on to the what are all the variables you are going to measure. As I told you here in the first slide, variables, plant variables. Okay, so what we are going to learn? What are all the things which we are going to know? Parameters which we are going to monitor. One is mass airflow. As I showed you in the previous diagram, a block diagram, MAF, mass airflow system rate. That rate you are going to calculate. Exhaust gas oxygen concentration. Okay, exhaust gas oxygen concentration parameter or a variable data. Throttle plate angular position system you are going to monitor. Crank shaft angular position, that is in the meaning of RPM, rotation per minute. You nodirtira what is the speed ಅಂತ ಹೇಳಿದ್ರೆ tachometer you are going to monitor. So it is nothing but a crankshaft angular position, that is nothing but a RPF. Okay, then coolant temperature you are going to monitor. Intake air temperature also you are going to monitor. Manifold absolute pressure. Okay, MAP, map, it is short form is map. Manifold absolute pressure also you are going to monitor. Differential exhaust gas temperature also you are going to monitor. Okay, vehicle speed which is related to this one, these both are same. Okay, vehicle speed you are going to calculate. And last one is transmission gear selection position sensor also you are going to monitor. So such way what happens here, these are all the variable data which you are going to collect it. Okay, collect it with a different position with a different parameter, and it is given for your engine control system. Engine control system, that is inside, if you see, we will be having your microprocessor, or a microcontrollers. Okay, I hope you have understood uh, what all these things are. One is sensors, actuators, and your block diagram. What are all the sensors are connected? What are the actuators? Sensors, how it is be connected with your engine control systems. Okay, and what are all the variables you are going to note down, which will be helpful for your car or any of the vehicles? Are these things? Totally 10 variables will be there. Okay. Okay, so based on this, the sensors will be operating. Okay, that is only here. Next point is engine control is based on the status of the vehicle. Okay, engine control is based on the status of the vehicle. There will be a set of switches. Okay, so what is that? Air conditioner clutch engaged. Okay, brake on and off, means this is the way the air will be inletted. Simply we cannot directly inlet the air into the wall of an engine system. Okay, certain things, certain devices we have to use it. So this is the diagram of a device which is called as a air mass airflow sensor. Okay, so here you can see the mesh part will be there. This is the physical structure of your MAF. Okay, in VT exam they may ask you how these sensor works. Explain about MAF. Don't get confused that mass airflow also same thing, MAF also same thing. Okay, so what happens, the air will be inletted here. Okay, so based on the inlet of a air there will be a sensors connected here, that is called as a hot filament. Okay, so hot filament flow will be there, so it will calculate and outlet will be in this direction. Okay, so this yellow part which we can see here is mu c or a mu p. So this is the practical device which it will be available in vehicle system. Okay, so this is the German made company where it will be produced, production is been done. Okay, next, see, for certain few points are there. It is fitted between air filter and intake manifold. Keep in mind, it is fitted between air filter and a intake manifold. The task of the air mass flow meter, what it is going to do, it means it measures fresh air converts amount of air drawn into the engine into a voltage signal. Okay, basically we use a concept called voltage to frequency converter. Okay, voltage to frequency converter. As I told, output will be always in the form of analog anta ಹೇಳಿದ್ದೆ. Okay, so ಅದರಿಂದ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ analog data na it should be converted into frequency anta ಹೇಳಿದಾನೆ. But the thing is that it should be in a digital form. Basically automotive electronic students, mechanical students, they call it as voltage to frequency, but we call it as EC students as a analog to digital signal. Okay, so this is the definitions. And coming to the circuit, how the circuit works, internal circuit works. We have saw the whole there is a of electronic circuits. Okay. Okay. So we can see that device which is made up of a bridge circuit. You could have studied in electronic instrumentation subject. Okay, bridge circuit, Wien bridge, some of the bridges you could have Maxwell bridges and all. Okay, so let's see how these things are worked. See, as I told you in this diagram, there is a hot filament will be connected and that. Okay, so in the bridge, what you are going to do means here it is a hot filament. Hot filament will be connected. Okay, filament will be connected. So initially, what happens? R1, R2, and R3 are the bridge circuit. Okay, so in this is bridge circuit, which will be connected one part as uh, uh, a sensor, a hot filament sensor, and rest of all your R1, R2, and R3 will be constant. Will be constant resistance. Okay, constant resistance. Initially, what happens? No airflow will be there means no airflow will be inletted. No airflow will be in this direction. What happens to the bridge? It will be in balanced condition. Okay, so VA and VB are the potential difference voltage we'll be getting, which will be connected for your differential amplifier. Okay, we know that what is differential amplifier? It is a op amp. It is a op amp. Okay, it is a op amp. So what happens? Initially, no airflow means balanced condition. Whenever the airflow happens, what happens through this filament, which is connected to the device, the bridge will be unbalanced based on the inlet of this one. What happens? VA and VB will be there, which is connected to the op amp of minus and positive, positive and a minus symbol. So here the differences of this VA and will be calculated. We'll get a signal in the analog form. Analog signal will be and this output is given for your mu p or the bridge will be whenever this particular you are going to convert your voltage to frequency converter. That is nothing but a whole circuit is nothing but a electronic gate between the this concept. Okay, B equals FT. B means BC frequency of T means duration. At what duration it is going to flow. Okay, so BC means binary counter. BC means binary counter. Okay, so B is equal to FT. So B is equal BC count, which is equal to frequency of voltage to frequency converter, and how much duration it is going to calculate or ensure that your gates are opening and closing. Okay, so indirect measurement of mass airflow. An alternate method, as an alternate method, we are going to calculate airflow. And alternate to the direct Mars airflow measurement in the form of so-called speed density method. Basically, we do in the speed density method. One more method, indirect method, is your speed density method. In that speed density method, what is that we have is manifold absolute pressure, RPM, or inlet air temperature. Okay, so manifold absolute pressure, RPM means rotation per minute, and your inlet air temperature. Okay, so here manifold absolute pressure is a sensor. Okay, it is attached to the intake manifold of an car engine system. Where exactly the map is connected? Map is connected to intake manifold on a car engine system. Okay, what it does, basically, what it does, map sensor respond to the changes. Map sensor responds to the changes in the intake air manifold pressure or a vacuum. Okay, and provides a reading for an engine load. How much engine load is being taken, that is being calculated by a map sensor. Okay, so this is the point which we have to remember in the map. Map means manifold absolute pressure. So certain short forms you have to remember, otherwise it will get confused while writing in the exams. Okay, how this map sensor works. Okay, let's see. Next, the several map sensor configured being used for the application of your automobiles. Okay, certain applications are there. Okay, so earliest sensor were derived from. So basically, before map, we have earlier sensor is called as a airspace instrumentation concept. Okay, basically we call it as airspace instrumentation concept. This provide more expensive. It is a bulky also and more costly also. Okay, none of map sensor is measure manifold directly. That is also very important point. Measure the displacement of a diaphragm. We know that displacement, transducer, diaphragm, these are all the keywords you could have studied in your diaphragm. Changes happens. Okay, here let's see what is diaphragm is. A diaphragm is a sheet of semi-flexible material. Okay, a diaphragm is a sheet of semi-flexible material anchored as a periphery, and most of it is will be in the form of round shape. Okay, it will be in the form of round shape. It's serves either as a barrier between the two chambers. Okay, then diaphragm is like a pump, uses diaphragm to pump a fluid. Okay, diaphragm pump uses a diaphragm to pump a fluid. Okay, and typically it is used for the pressure measurement and all. Okay, just a minute. Okay, so here what happens, diaphragm is a main key sensor or a sheet which is used to measure the variations of your pressure. Okay, then next part is next part I will take it in next class. I'll stop it here itself. Okay, because it is a very lengthy topic, and we are going to cover it in the coming classes. I hope today's class you have understood. Okay, what are all sensors means, what are all the actuators means, what is the flow diagrams of your sensors which will be connected, and what are all the variables or a parameters or a data you are going to calculate. Okay, so based on that, the first one we have discussed mass airflow sensor and how it is made up of, and how your circuit diagram for your mass airflow. Okay, and what is the formula for that, and what is the indirect method of measurement of mass airflow, and your map sensors, how it works. Next, we'll take out strain gauge sensor in the coming class, and we'll cover it because it will take more time to explain this one. Okay, so any doubts? Is there any doubts? I hope you have followed and whatever the instructions I have given. So based on that, please read well for your exams. Okay, any difficulties in topics, please communicate with me. Okay, um, just a minute.